clicking on, here we go, distributive property. See how lessons have an I can statement, like what do you want to be able to do? I can use the distributive property. Okay, that's the goal of today's lesson. I want you to be able to use this if you find a math problem that's too hard on the milestones. Okay? So again, we'll look at the word distribute. I used to pass out. So if I have like 6 apples, right? 1, 2, 3, 4, 5, 6, and I distribute them to you guys, I could go 1 to Sebastian, 1 to Gabriel, 1 to Sebastian, 1 to Gabriel. And I'm distributing the apples, okay? We're putting the big number into smaller groups. So how we're going to use this with math is if we find a tough problem that we don't know, like 7 times 8, and I say, I don't know what that is. But what I do know is I know some smaller numbers that I can multiply by 8. Maybe I don't know my 7s, but I can break up 7 into some smaller numbers, okay? So what I might know is 2 and 5. What's 2 plus 5? 7. So this is the same number, okay? So if I break it into smaller numbers that I do know, now instead of writing 7 times 8, I can write 2 times 8 plus 5 times 8. Does that make sense? So see how this right here is the same as this. All that I did was break up my 7, okay? So that's 2 and 5. So now if I did 2 times 8 is 16. And I know 5 times 8, I know my 5s, I can count 5, 10, 15, 20, 25, 30, 35, 40, okay? That's 40, and I add these together, and I do 16 plus 40. What's 1 plus 4? 1 plus 4, right? You had the 5, right? 5, and what's 6 plus 0? 6. Thank you. So I have 56. So now I didn't have to multiply this number, but I know that this big number now is up to 56. And we didn't have to count by 7s or count by 8s. We broke it into small little numbers that we do know, right? Okay, now I'm going to draw it with some shapes to help us see. So we had a number like 9 times 6.
Fractions on the other line.
And I have
You don't know how to do fractions? Like, you take
9 times 6.
and you just broke it up into
1, 2, 3, 4, 5, 6, 7, 8, 9.
And then you go to the next
do that.
part and you start all over again. You have to have
6 times.
That's your score right here. 33. That means basically almost nothing. Like if you got 50, you get half.
Okay, so I have all these circles, and these are circles. And I think, okay, here I have, we count over, I have 9. And here I count 1, 2, 3, 4, 5, and I have 6.
Are you practicing
Okay.
medicine like SRT?
So I have 9 times 6, so a slow way, I could count every one of these circles.
You're not like practicing and thinking.
Remember how we did it with those red squares when we were finding area? I could count every one of these, and I could find my answer. But that could be, that's kind of slow, and that could be really hard. If I have a big number, if I have like 10 times 20, that's too many to count. So instead of counting them, we can break it apart into smaller ones, just like we did with the last question. So if I just draw a line, and I break it down the middle, now how many do I have here, Gabriel? How many circles are here? Right. Now this is a 5, and how many here? Right here. 1, 2, 3, 4. See that, Sebastian? So now, this whole row, we still have 9, but we're going to break it up into 4 plus 5.
Sebastian. I'm sorry, he's back there.
So now, our new writing, we would, instead of saying 6 times 9, we could do 6 times 4 plus 6 times 5. Does that make sense? Do we know what 6 times 4 is? What's 6 times 4, Gabriel? Right, 24. plus, and if we know 5 is 1 more than 4, we just add 6. What's 6 times 5?
8.
Good, 30. And then if we added up 30 plus 24, Gabriel, what's 0 plus 4?
4.
And Sebastian, what's 3 plus 2?
So you're gonna do perimeter, right?
5. 54. And if we counted up all these circles, we get 54. Okay, but the purpose is that what they might ask you on your milestones is, I have the numbers, they might give you the broken up, the distributed equation. They might say, our same example, 6 times 4 plus 6 times 5 is what?
Yeah,
And it's going to ask you, what question would that be?
yeah, go ahead.
So instead of breaking it down, we can also work backwards and we can put it together. Okay? So when we're going to do that, the first thing we're going to look at is that both of these have one number that's the same. What number do they have that's the same?
You want the original?
6. See how, Gabriel? Okay, so we're going to keep our 6. It's going to be 6 times something. 6 times 4 plus 6 times 5 is the same as 6 times something. This could be a question we see. And the is very simple. It might look like a lot of numbers, but all we're going to do, since we kept our 6, we're going to look at what we're multiplying, and we're going to do 4 plus 5. 9. Remember, that's the same question we had last time. So that might ask you to put it together, or maybe you could ask something like
Rewrite it.
7
Rewrite it.
times 3 plus 7 times something is the same as 7 times 5. So, the first thing we look at again, what number is the same here? 7. We have our 7, so we're not going to look at the 7s. We're looking at 7 groups of something. Okay? And I know, if we look up here, we had 4 groups of 6 plus 5 groups of 6 is the same as 9 groups of 6. We're just how many groups of 6? So here we have 3 groups of 7 plus how many more groups of 7 give me 5 groups of 7. Perfect. And how'd you get to? What did you think of you had to do with this 3? Did you multiply? Did you add, subtract? You added, right? So you see how we're just adding the groups that we have? So here, we're distributing. We have 5 groups. I might distribute. Here you have 1, 2, and you can have 1, 2, 3. But all together, they come back and it's a total of 5 groups. Okay? So we'll do another practice one. We had 4 times 1, so 1 group of 4, plus 4 times 6, 1 group of 4 plus 6 groups of 4, is how many groups of 4, Sebastian? I'm going to fill in our last number. We have 1 group of 4 plus 6 groups of 4. How many total groups of 4 is that? We're not looking at the 4s. All of our 4s are the same. Okay, so here we're just talking about groups of 4. So if we have like 1, 2, 2, 3, 4. Here I have 1 group, and here I have 1, 2, 3, 4, 5, 6 groups of 4. So right here, I have 1 group, and right here I have 6 groups. So all it's asking is, if I put all of these groups of 4 together, how many total groups do I have? 6 and this group. Plus 1 more. It's groups of 4. But if you add the group of 6 plus the group of 1, how many groups? Look here. Count how many groups. We have 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups. 6 plus this one. 7. And all we did here was 6 plus 1. Okay, so all we're doing is we're finding how many groups, because this is all, this right here is 4 times 7. And we broke it into 4 times 6 plus 4 times 1. Okay, we'll try working the other way again. We're going to type one for Gabriel. We have 5 times 2 plus 5 times 6. And it's 5 times how many? So I have 2 groups of 5 plus 6 more groups of 5. How many total groups do I have? Gabriel, this one. 8. So hold on, I don't want to go too fast for you, Sebastian. So we have all these multiplying. There's a lot of numbers. Alright? So here, we know all of our 5s are the same. So we're just talking about groups of 5. Okay? So here, I have 2 groups of 5. And here, you can have 6 groups of 5. Okay? So I have 2 groups, and I have 6 groups. And if I add them together, 2 plus 6, what's 2 plus 6?
So he has 5 pieces.
That's how we get the 8. All we're doing is adding the amount of groups we have here. And then we can also distribute them. Now 8 is the same as 6 and 2.
He has 2 big parts. He has 2 small parts.
Alright, now I'm going to draw some other questions we might see. If I have 7 times 2 plus 7 times blank, it's the same as 7 times 6. And then I'm going to do another one. Okay, so I have 2 different questions. And we have blanks on different sides of the equal sign. 2 different times we could see on our milestones. So after we do this, I'll let you guys go. Okay? Gabriel, can you tell me what goes in the blank at the top one?
Brianna, you got it wrong. Brianna?
Okay, good job. You can go sit down.
Same part.
Sebastian, can you tell me what goes in this blank down here?
He has 3, he only
I
has
have
4.
5.
He has more. There's 3
And how'd you know that?
pieces, 1 piece? 1 piece? 3
It's 7. And you see how he did this one up here? He didn't do 2 plus 6 is 8.
Is it 3 pieces?
No, he did 2 plus, how many more do I need to get to 6?
And you have
And he
1
found
piece, you have 4.
So do we understand that what's important
I do.
is that we're just taking
Because the denominator is
groups
the same.
of big multiplication numbers. Now that we can break them down into little groups to make more sense, right?
Here,
Okay.